Okay, we continue. Last lecture, we look at reliability. Last lecture, we look at reliability. So there's an equation to use for parallel and serials. So, and then how many backups you need to achieve the reliability of a certain spec. Okay. We continue. So from the design chart, okay, from this design chart, previous class, we start from idea generation, go to feasibility studies, go to rapid prototyping, then go to pilot run and final product launch. We already cover how to do idea generation. We already know how to do feasibility studies. Okay. And important when you answer the question about this design process, remember to write what is your input, what is the output. Okay. Um, then we go into rapid design. Rapid design got three process, parallel process, form design, functional design, production design. Okay. So we have done functional design. Functional design, one of the functional design is the reliabilities. Okay, how reliable it is when the object is performing. Okay. Today we'll go into functional design. So there's one equation to calculate how frequent the failure will happen. Okay, we define these reliabilities with a name called mean time between failure, MTBF. So MTBF give you by this equation 1 over failure rate. Failure rate means the frequency of failure, like one failure over 1 hour or something. So it's an inverse of your failure rate. Okay, MTBF. So MTBF. So for example, if your laptop battery fail 4 times in 20 hours, so every 20 hours, your battery will fail 4 times. So the failure rate will be 4 divided by 20. So it'll be 0.2 over hours. Okay, 0.2 over hours. So you inverse this value will be 1 over 0.2 will be 5 hours. Okay, you inverse it is 5 hours. MTBF. MTBF is mean time between failure. Mean every 5 hours you have one failure. Every 5 hours you have one failure. So this is what MTBF mean. MTBF mean. So what can you improve the reliability is all this point lah. So your question, if the question come out to ask you about reliability, one is the calculation for parallel, serials, and then how many backups you need. Then the last part of the question will ask you how you improve the reliabilities. So these are the points that we expected from your answer. So it can be improved by simplify the design, make the design more simpler, improve the reliability of the individual components, means the R, R1, R2, R3. Product are easier to manufacture or assembly. This one also another one. Well maintained, and you give training to the users. This one, how this one apply in the real case? They will supply you with the handbook, operation handbook manual, or some of you ask you to go to YouTube and watch the video how to maintain the things. Okay. Or if you buy the premium car, like for example, Lamborghinis, those sport cars, premium sport cars, they will require you to go and attend a certificate of driving sport car before you can before they deliver you your car, something like this. So all these are definition. This one you read lah. What is maintainabilities? All these things. Okay. So all these you read lah. All these read. Another word is just now you learn about MTBF, mean time between the failure. Now you have another calculation for mean time to repair, MTTR. Okay. So your overall systems availability will be MTBF divided by the two failure component. One is between failure and one is mean time to repair. Mean time to repair. So this is second equation for today. Okay, so SA equal to MTBF divided by the combination of MTBF plus MTTR. So I'll give you the tutorial on this one. Okay, so ME must choose a service provider for its company. Other factor being equal, she will base his decision on server availabilities. So mean SA. Given the following server performance data, which provider should he choose? So you have A, B, C, you have MTBF, MTTR. So you need to use this number and substitute in this equation. Okay. So system abilities SA equal to MTBF plus MTTR. So if you use this equation to make assessment, you have three data you need to calculate. So if you calculate the data, which one is more reliable? Okay. So SA will be 60 divided by 64 will be about 94%. SB will be about 95%, very, very close. So in your answer, you can do 3 decimal place or 3 significant figure. Then you will see, for this module, if you have a very near one, you extend your answer to 4 decimal place. Okay. So as this is C, should be C, typo error. As a sub C, not A, you'll get 96%. So from here, you choose company C or provider C for the server service because their service availability is 96%. Means they are always there compared to company A and company B. Okay, means their service available to you at 96%. Okay, this is another exercise, as example 2. So of course, this one, this person trying to decide internet services provider, his friend always complaining about the service, how long it takes to get the service up and down again. So Amanda is a conscientious student. So he collect data, meantime, and MTBF and MTTR for 3 internet service provider. Given that cost and speed are comparable, who you will recommend? So this one same. same formula, SA equal to MTBF divided by the total of MTBF and MTTR. So if we do calculation, okay, you'll get 95%, 90%, 93%. Okay, so this one, so you will choose the highest one, Mostel. So this basically is a bonus question. Nothing complex here. Okay. So another keyword here is usability. Usability, you elaborate lah. Easy to use. Okay. Easy to use. You can use this 4-point or 5-point to elaborate, right? So if we go back to the milk products, if the question still ask you about milk products, so how you elaborate on usabilities of milk products? So does your milk products easy to use or not? Or does it easy for the user to use intuitive, means common sense to open up the container? Okay. And then can you avoid error or not? Like for example, some snacks, there's only some snacks that give you like very clear indication. For example, you see McDonald's, KFC, the chili packaging. This is the two side lah. But you see that the chili packaging, they got one gap here. So, or some snacks, they give you one notch here. So you know where to tear. This is a common sense, for example, the common design. So for your milk products, your container also should easily to access the milk. Okay. So these are the functional design from the Apple products. Okay. So if you look at the earlier design of electronic products from Apple, all of them are quite direct. When you receive the product, you know how to turn on, you know how to play the products, how to open up the products, and so on. Okay. Production design is more on the process, how the product is being made. Okay. So sometimes we as an engineer, we tend to over design the products. Like for example, you have lots of function, lots of option, lots of parts. Okay. So back to the milk product, how you elaborate is that when you talk about production design, you should your product is you mentioned your product is using a simplified milk process by simplifying the features, option, and the container parts and so on. Okay, so how do you further elaborate on a production design? You can use simplification, standardization, modulation or modularity, and design for manufacture. Okay, you can elaborate on these 4 points on the milk products. So what is simplification? Simplification means you reduce the part, sub-assembly, and option. This one, if you take the PC laptop, for example, the number of parts for PCs is very simple. Or things that you buy from IKEA or IKEA, they are very, very simple parts, where the user manual also very simple. They point part 1, part 2, and they will give number to that. It's like fixing a very simple Lego. Simplification also, they avoid using tools. So some of the, like for example, if you buy a gaming PC laptop that you do self-assembly, nowadays you want to change the processor, the IC chip, it's very easy. You just need to press, and then there's a spring mechanism to push the object out. Okay. Sometimes also if you're installing RAM before, the computer RAM, there is exactly some slot you can slot in. If you install the wrong direction, you cannot slot in. Something like this. Most of the design nowadays using Pokayoki design. Pokayoki means void error design. Okay, simplification. So let's say you have this original design. Let's say, so you have a design, original design, you want to make a container. This container consists of all these screw, all these parts, right? So you want to design a toolbox. So they want the company intention to they want to automate the assembly. They want to automate the assembly means they want to buy robotics arm to do the process. So this is their early design for the toolbox. So this toolbox contain what? Contain 24 parts, mostly bolt and nuts. So they have, you count lah, got 24 assembly. Okay. If you come in now, you consider late for the class. So this design, if you count, you got 24 common parts and require, if you assembly, you require 84 seconds to assembly. If you tell some operator, okay, go ahead assembly, you count from the first screw you screw in until the last screw, you need 84 seconds. So this design does not appear complex for manual assembly, but it do require complicated for a robot to assembly. So how do you use this simplification, standardization, modulation design? Okay, standardization means standard way of doing it. Like process one, you must mix with 10 ml of something, then you go to the heating process and so on. It's like a cooking manual, this one. Modulation is like computer. You modulate means like RAM, you can assembly the RAM and all this, like Lego bricks like that. Nowadays, the civil engineering, they also use modular design, where they build houses with precast, like Lego bricks. They send the wall already precast, then they assembly. They slot in, slot in, slot in. Design for manufacture, this is more on the design. So we still back to this example. So how do you further simplify? If you are engineers, how do you simplify this design? What will you do? Let me see if I have, okay. So the first thing is to simplify by eliminating the fasteners. Okay, let's say the chief engineer tell you, okay, now we have this origin design and we want to eliminate the fasteners. What kind of design you can come up by eliminating the fasteners? Okay, maybe I'll give you 1 minute to think about it. How? How would you eliminate the fasteners? Okay, so actually the answer is inside this slide only lah. Okay, by molding the base as one piece. In this one, the fasteners so you can see, eliminate the fasteners, all these things, by joining the base. Okay, by joining the base. So the revised design, they eliminate the fasteners by using it as one piece, and they do sheet metals bending process. So they eliminate, then they use a plastic insert. They propose a plastic insert to secure the rod here. Okay. The assembly time reduced from 84 seconds to 12 seconds. Can you further improve this design? There's one more slide I'm going to show you after this, which is the optimum design, transferring from 84 seconds to maybe 2 seconds or 3 seconds. You are making a toolbox in this shape with a handle, and you can install something in the middle. So now you already iterate your design, you already revise your design from 84 seconds to 12 seconds. Can you further improve the design? Yes. So you can just further improve this design by, okay, so this one, if you improve from here to here, the assembly from 42 assembly per hour into 300 assembly. So this one you need 84 for one assembly. So in 1 hour is roughly 300 for 43 assembly. If it includes, it reduce the time to 12 seconds per one assembly. In 1 hour, you can assemble 300 assemblies. It means you increase your production. Okay, so your design trim can remove these two cap, because here you still need to put in the cap. So you can further simplify this design by using a spring mechanism, a spring design, where you just need to cut the two slot here, because metal got spring or elastic properties. So what you need to do is you only need to fabricate two parts, then ask your operator just to push in the things. Okay. And you can just pay your operator maybe 1 hour 30 ringgit Malaysia, just to do pushing. Or 1 hour stand there station, do nothing, just to push, 30 ringgit per hour. Compared to buying a robotic arm that costs million just to push the thing, not worth it. So reduce from 12 seconds to 4 seconds. Okay. It can now change from 300 assembly to 900 assembly in 1 hour. So this is a production design. So automation is not necessary in this case. All right. So your test 2, you might be given a scenario for question 2 to further improve the design by using simplification approach. Okay. So you'll be given a scenario, of course, not this one. You're asked to apply simplification, standardization, modulation, and design for manufacture. Okay, this one will be question 2 lah, test 2. So you need some time to think about that, because you're taking, again, you are taking degree level engineering degree. You'll be assessing your innovation part, the way of your thinking. Okay. So if you want us to issue you a certificate, then you no need think one. You just memorize and go in, then we'll give you certificate level. If you want to go into degree level, then you need to think a little bit, show the competency in thinking. Okay, do analysis, argue statement with scientific finding and all this. Okay, standardization. This one is the keyword here. Standardization is using interchangeability of parts. Okay, for example, batteries of your laptop, but nowadays laptop already built in. That will create a good turnaround ROI for the laptop manufacturer, because why? Once they put in the battery, no battery have lifetime. So when your battery gone or your battery broken already, you need to change the whole laptop. Same with the current handphone also. So your handphone, your lifetime for your handphone might not last more than 10 years, right? So this is on the economic consideration. But I think 5 years ago or 10 years ago, the computer that you see, it come with this interchangeable battery. You know, if you still remember the old handphone, mobile phone, all the mobile phone battery you can change one. But nowadays battery all cannot change, all built in. Okay. And also when you have interchangeable means people will copy your products and they will sell at the lower price. So actually, not very good in the business. Good for the consumer, but not very good for the founders of the designs. So standardization, the advantages is this one, higher volume production, competitive advantage, and so on. Okay. Okay. Now light bulb, all these things you can change light bulb, all these things. These are called standardization. For milk products, what are the things that you can do standardization? Milk products. Milk. Back to the problem that we face. Earlier we discussed about milk products. You need to develop a new milk products, right? How do you do standardization? How do you elaborate on standardization section? Use milk carton, no? So standardization means the size always same, or you factory already have the same carton design. You just use back the same size of the milk product. You just change the design of your, I mean the picture of your carton only lah. Okay. Okay. Another standardization is that if you're selling milk products, the bottle, the glass bottles, that one also you can standardize. That become part of the standardization lah. So when every time people see your glass, you know that this you actually your customers, or you can change the milk. Like for example, early morning maybe people put the empty glass milk in front of the door, so the delivery guy will go and collect the milk and change the glass bottle with a full milk with a new fresh milk lah. This is also standardization. Okay. Modular design is the same. Like if I use laptop, then all of you can understand. Modular means you put in small blocks. Automotive industry, for example, or Toyota, they use the same body chassis for Camry, Corolla, Lexus products. This strategy also used by other premium car manufacturer, Mercedes-Benz and BMW and so on. Okay, of those high premium, for example, Lamborghini, sorry, they are custom made the car. They don't use same chassis. Okay. So another example is a Campbell Soup Company. I think you know what is Campbell. How they do modular? They start with 4 basic blocks. 4 basic soup, beef, chicken, tomato, and seafood. They mix around, they can come out with 125 products. Means they have the 4 simple block, then they mix around, they will come into 125 products. So also this is also a smart way of doing business, right? So for example, in food industry, you go to hawker center, those that selling let's say chicken rice. Chicken rice store, actually he can open up another products where selling soup, chicken soup or chicken porridge and all this, because he's selling the chicken bones and all these things. So this bone can be recycled, become broth, and this broth can become other products. Okay. Design for manufacturer, this one we call it DFM, design for manufacturer. Designing a product so that it can be produced easily and economically. So this one is more on the jig, more on the process things. For example, milk products, you already have the facilities, you only need to interchange some of the parameters. Okay. So these are the benefit lah. So this module, we always like to ask you benefit, advantages, disadvantages. So you need to elaborate on this. Okay, guidelines to have a good design. So these are the keyword lah. So like for the milk products, you minimize the number of parts and this one, you minimize the process of making new milk products. You avoid those fasteners and adjustment. This one for milk you don't have fasteners. All right. So what mean? How you simplify means you reduce the mixing process or ingredient that you need to mix in. So you maybe raw, then you mix in one ingredient or one new flavor or something. Right? The question asks you about developing new products. They do not ask you developing complex products. Right? So don't overthink the question. Don't overthink the question. Okay, design parts for many users. So means your product you can extend to other products. For example, the broth just now, the Campbell broth, 4 basic soup, but it can extend to 125 different products. Okay. Okay, then we have this. We already covered form design, functional design, production design. The output will be 2. Output will be design specification and manufacturing specification. These two don't mix together. One left-hand side is design, right-hand side is more on the manufacturing. The output will be 2. Input go into pilot run and final test. So this one you read lah. You read. Okay. Design specification is more on how the product is to be produced, and manufacturing specification is more on intent of design. This one you read. So final design, the output from here, final design will be detailed drawing and specification of new products and services. So back to the milk question. The milk question you mentioned, the output from pilot run and final test will be the final design consists of detailed drawings or detailed process for the milk and specification for the new milk products. So this one is what we expected from your answer. You need to link back the question. If you copy this one, memorize this one, and then you put inside your answer, you don't get the full mark because you do not link to the question. Okay, the rest you read. Okay, we have done the major part for your final exam, question 4. Already completed. Then also you cover your test 2, question 2 question. Now we go further elaborate a little bit. The rest you read. The rest you read. So we will give you a quick introduction on planning, process analysis, innovation, and how you do decision. So this one is a chocolate process. This you go YouTube and watch lah. This one. This one is hazy chocolate. You explain why. Have you wondered why all the chocolate they use aluminium? This video explain why they use aluminium. Yeah, why don't they just use a normal white? Why don't they just use a recycle plus newspaper or what? Why don't they just use a cardboard to wipe it? Why they always come with the aluminium paper? There's a knowledge there lah. Okay. All these definition you read, process design, process strategies, right? All these lah. Vertical, all these things you read lah. Lots of theory here. Okay, I want to highlight this one. So when you integrate something, especially your technologies, the left-hand side and right-hand side, vertical integration, this is on the outsourcing decision. So you need to consider like how you source for your ingredient. So on the left-hand side is vertical integration. You can see from cattle to slaughterhouse to so and so, and then you get the slice of the meat. Okay. This is vertical integration. Horizontal one will be like oil and gas industry. Yeah, for all the pipeline, all the oil rig, they will channel the oil into one assembly plant and all this. Okay, this is integration. So you purchase the competing companies in the same the same industry. And this one you purchase of companies at all level production. So this one, vertical integration got one problem because they cannot make all the parts that go into a products. So that's why nowadays a normal company they will buy parts from the vendors. For example, let's say we take automotive industry, the 4 wheels they will buy from the wheel company. The tires, all these things they will buy from Michelin or all these things. Then they supply, then they assembly. Okay, it's much cheaper you buy from vendors compared to invest the whole technologies just to produce the tires. Okay. Okay. This one you read. Okay, these are the questions that you ask lah. Read. So these are the factors that you consider. This one is important. For outsourcing decision is based on a few factors. Of course, money, the first one, capacity of your companies, quality, speed that you need, I think reliability, expertise you have, all these. So these are 5 factors in the outsourcing decision: cost, capacity, quality, speed, reliability, and expertise that you have. Okay. So we can summarize what is project, batch production, mass production, and continuous production by this simple chart. On the y-axis is volume. Volume means the production volume, how many parts that you can produce. X-axis is the standardization, means the process that you can standardize, or process that you can fabricate in the same way. So the lowest one is project. Projects, you don't need high standardization, you don't need high volume. You only need project. Usually they are low volume and only require low standardization. Then you go into batch production, you go to mass production, you go to continuous production. Okay. So projects will be like assembly a ship. 1 year or 2 years, you only can build one ship. Very low and low standardization. Batch process will be like making the braids and all these things. Right? Mass production will be like glove factory. Continuous will be like oil and gas. You need to always dig, and okay, so this table is important. Go and read. Right? What are the differences from project until continuous? Type of products, type of customer, demand, equipment, all this one you read lah. It's very boring if I go each one of it. And you have seen how I asked your question, your test one. So if there's a table, then you pay attention. Okay. These are the technical words when you go to industry. What is item? What is inner pack? What is case? What is pallet? Okay, the term is here is different. So the volume involved also different. So if we talk about cost, we have fixed cost like equipment, variable cost like labor cost. Okay, labor cost. Why labor cost varies? Because different expertise we pay you differently. Operator pay differently compared to designers or engineers. So total cost will be combination of fixed cost and variable cost. Okay. So in the equation, you remember this formula, TC equal to CF plus VCV. This is total cost. CF is fixed cost. And because variable cost is variable, you need to multiply by one variable. Like for example, 1 hour, 10 ringgit, you multiply by 10 hours. So you get the total cost. Okay, this is how you calculate. Now, revenue, again, revenue is what? Revenue is a price at which the item is sold. So if the car is sold at 100,000, then your revenue is 100,000. Okay. Total revenue is price per unit times volume, means total money you put inside your pocket. Total revenue. Okay. TR equal to volume multiplied by the each piece of the price. So P also means revenue. So when you multiply your revenue with volume, you get total revenue. A profit, you know lah. Profit means total revenue minus your cost. Total money you collect minus the total money you pay outside. So Z equal to this one minus this one. Okay. Or you don't need to memorize this one. This one just a substitution of value from the previous one. Nothing complex. Okay, I'll give you one example very quickly, then we call it a day. When TR equal to TC, means total revenue equal to your total cost, it means it's a break-even point. You don't make money, you don't make profit, also you don't lose money. It's a break-even point. In business, we don't go for break-even point. Of course, it's a consideration in the early decision, but you don't want to see open up a business, then you always break even one. You don't want to see that, right? So if you substitute the value, the equation just now, total revenue equal to price by multiplied by the volume of that unit. Total cost is you have two fixed costs and variable costs. You combine. Okay. Now that you see the same same variable here with its volume. So you want to factor out the volume. So this is just a mathematics procedure. You move the V component to the left-hand side, then you can calculate the break-even volume for the business. Okay, this one works when you work it as a hawker operator. You want to know in one day how much bowl of the chicken rice you need to sell to break even. Or if you are the coffee shop boss, you need to know, or in one day how many cup of coffee you need to sell. Okay, this formula, it comes from this general equation. Your total revenue equal to total cost. Then you expand from there. Okay, let's look at this case studies. So there are two good friends, Tarif and Jeff, T and J. These two friends, T and J, they are good friends. They start up a company. They are selling stand-up right pedals. Blah, blah, blah. This one is just an elaboration for the question. So this is the right up pedal where you stand upside the devices here, or these tools here, then you roll to as a sport, water sport. Now, they go and do some survey. Stand-up pedal are similar to surfboard appearance, but this is more on the explaining what is the stand-up board. So the board are constructed from blah, blah, blah. This is an important statement. Unlike surfboard, for market 500 to 1000 is the pedal board is typical show for 100 to 400. This is a market range. So this one, this is the starting of the question. The front one is elaboration just to prepare the student to understand what is the object, what is the scenario. Then the important information is here. So T and J, they want to start to do break-even analysis. So they anticipate selling the product of 100 each. So this pedal, they sell 100 each. Key estimate fixed price of the equipment will be 2,000. CF if 2,000. Material and labor will run cost 50 per unit. So another one, 50 is variable cost. Multiply by V. You need to multiply by V. You don't know your V. What volume the demand will be necessary for Travers and Jeff to break even? So you use this equation, TC equal to TR, substitute the value, you arrive at one number. So this one, I just go very fast. I already explained how to get this one. You just substitute. Of course, this one come out in exam. You need to derive from TC equal to TR, then explain how you get this one. In exam, you need to develop the equation. Okay, you put in the things, you at the end, you arrive at 40 units. They need to sell 40 units to break even. Now the scenario change a little bit. Okay, sorry. This one is break even. This one, it come out a bit early. So ignore this one at first. If you look at this equation, you look at this equation, do you see this one as linear equation? Y equal to mx plus c. You see this? TC equal to not TC. Yeah. Let me see. Money with units. Okay. This one, TR also. TC, TR. TR is VP. So this one is Y equal to MX plus CC is 0 for TR. TR and TC both have two linear lines, right? So this one, you can plot on the graph, you can plot these two lines. This one, total revenue, TR, is V multiplied price. So you can pick this one, and then you draw a straight line, you write TR equal to VP, this line. Then you substitute the value. What is your PP is 100, so this one is TC equal to 100 V. This is volume. Red line, how you find? Red line is TC equal to CF plus VCV. You intersect by fixed price. How you find fixed price? So the statement is here. Tables estimate fixed cost space will be 2,000. So you start with 2,000, then calculate the M, the gradient, then you draw the red line. So this will be 40. If you draw in the graph, you can find the intersection point. You extend down, you get 40. But by calculation, you already can calculate 40. Yeah. So the kind of question we'll ask you is to ask you to use formula and ask you to illustrate your break-even point with the graph. You should be able to do two sides. One is on the left, one is on the right. Any question? Can? Cannot. Simple, Okay. Okay, the rest you read. However, this good friend Jeff here, he say, means another director, another shareholders, he say, okay, so this one is more optimistic. He believe that demand for, this is Jeff, Jeff demands is better will exceed the break-even point of 40 units. Means Jeff, he very optimistic. He say that, okay, we can sell more than 40. He proposing spending 10,000 in fixed costs to buy automate machine, means buy robots and all these things, to reduce the material labor cost to 30 per bot. So if previously you need to spend 50 for the variable cost, but now it reduced to $30 when you buy the equipment, automate equipment. The bot will sell at 100, regardless which manufacturing process you choose. Compared to process, determine what level of demand each process would be preferred. Label T proposal as process A, J proposal as B. So on the same graph, you need to draw Jeff line. Just now, you already have these two lines. Okay. Now you want to make a decision based on scientific way. So how you do? This is T plan. Jeff plan is optimistics. The criteria is the demand will be more than 40. You spend 10,000 for machine, and labor cost reduced to 30. So what is the decision point? Whose idea is better? The question actually asks you, whose idea is better? Or how you decide whose plan is going? It's like two brothers. You go to the father, the main sponsor. Father, which plan is better? Then ask the father to make decision. Okay. How we solve? You come up with two sides of your paper. Left hand side, you go for process A. Right hand side, you go for process B. You need to find the volume at neutral ground. Means at what decision you follow process A, what case you follow process B. So this is finding the volume for both sides. So process A, is 2,000 plus 50 V. Right? Process A is the traverse plan. Because fixed cost is 2,000, labor cost is 100. You sell at 100, and then variable cost is 50. So you put in the total cost left hand side, total cost right hand side, left, right. Huh? So this one, the total cost is fixed price plus variable cost. What about B? B will be 10,000 plus 30B. Understand? Huh? For Traverse, for process B, how you write total cost equation? 10,000 plus 30V. Then you are solving one linear equation. Your V will be 400 units. When it reached 400 units, both cases reach at the same total cost. So if you understand this formula, you make decision. If the demand less or equal to 400 bots, you choose process A. Why? Why? And the demand, why you choose process A if your volume is less than 400? Why? Huh? Why? Why you choose process A, left hand side, when your volume is less than 400? Why? Think as a businessman. Your investment is less or less cost. Lower risk lah. Huh? Because if your volume is less than 400, let's say you take 300 or 100 lah. You take 100 here, your total cost for process A is what? Let's say 100 is about 7,000 lah. Let's say your volume is 100 lah. Left hand side is 7,000. Right hand side, more than 10,000, you know. So it's not worth it. However, if your process, your demand, your order is more than 400, you will go to process B. Okay? If you put in 500, your process A will give you more cost. Okay? Now, how you justify? Another graph you need to plot. If this kind of question come up, plot this graph. You know how to plot? The orange color, the blue color is this one. 2000, y equal to mx plus c, y is cost, x is your v. Y is this one. Y is y equal to mx plus c. This is your c. C is this one. This is mx. So you can plot the point, right? You can plot the point. Let's say 200, 400, 600, 800. Then you substitute value, you get the point. Okay, you get the point. Then right hand side, process B. Process B, process B, 1000 equal to 300. So you can see this one, You can see this one. So if the volume, the break even is here, 400. If the volume is less than 400, is the volume less than 400, area under the graph is the cost. You can see that the orange color is higher than the blue color. So you choose blue color. So here, if the volume more than 400, you will see that the cost for the blue line is higher than the orange color line. You always choose the low area when you do business. You don't want to put in money most of the time lah. So you choose by this one. So you explain by elaborating what case or what volume you need to make decision, which plan you follow. Okay? And so if you understand, we stop here. Okay, the rest I will just upload into Canvas and you read. Okay, sign your attendance.